Okay, Charles, how are we going to reduce this to a single number?
We're going to follow those steps that you have outlined. I don't know the answer, but I think I know how to get to the answer.
All right, let's do it.
Okay. So, well, first off, uh, are we doing finite or infinite here?
T equals 5, it says.
T equals 5. So we're definitely doing t equals. That's what I thought. Just wanted to be sure. Okay. Well, so all I have to do is actually turn everything that I see into turn the straight transitions into immediate reward. So I can do that. Would you mind writing some stuff for me?
Not at
Yeah,
all.
there you go. So let's do ones over the greens and minus zero point 0.2 over the reds. But actually, I don't really care about the one you just wrote down because it's more than t equals 5 away.
Ah, all right. Well, that's going to come up in the next step. Truncate according to horizon. So 1, 2, 3, 4, 5, cut. 1,
Mm-hmm.
2, 3, 4, 5, cut. 1, 2, 3, 4, 5, cut. Now, I was a little bit sloppy with how I defined the 5. It could be that you actually put it one step deeper, but I was careful to pick a horizon length so that it wouldn't matter which way you interpreted it. This would just add zeros to it. It wouldn't change anything. So
Oh,
anyway, here we are cutting it at 5.
okay. Very smart, Michael. All right, cool. So now that we've done the truncating, I just need to summarize each of the sequences in turn. So I know that whatever I would get for the first value would be zero point 0.8 to the 0 or to the 1. Where are we starting from?
That's another good question. So it looks, yeah. So that's going to actually change the answer depending on how people interpret that. I would say that what this is, to take this literally, that we're talking about the first reward, being R1, and then the next one being R2, R3, R4, R5, and the gamma corresponds to the index number here.
That doesn't seem right.
Yeah, but it is what it is.
Okay. Seems like it should be 0, 1, 2, 3, 4.
Oh, I see. If you call the first one 0. Oh, I like that better.
Mm-hmm.
But probably for the quiz, we should accept either way
Sure.
or either way.
Or either way. Okay, so now that we know what where each of the rewards is, that's pretty easy. Actually, I think that's going to work out pretty well for us. So then for the first sequence, I know it's going to be 1 times 0 plus zero point 0.8 times 1. And actually, everything else is 0, so
Yep.
we
So
know the
this
value
this
0.8.
first sequence actually has a return of 0.8.
Right. So the second sequence is pretty similar. It's going to be 1 times 0 plus blah, blah, blah. So that's 8 to the third, or 0.8 to the third times 1, which is some number. Okay, so the return for the second sequence is 0.512. So for the third sequence, we're going to do the same thing. It's going to be 0.8 to the second power times 1
First power.
to the first power. Thank you very much. 0.8 to the first power times 1, which is in fact 0.8, plus 0.8 to the fourth power times minus 0.2. All right, so we got 0.8, 0.512, and 0.71808.
Mm-hmm.
And so we just have to add those together, get an average, but a weighted average. So it's going to be 0.8 times 0.6 plus 0.512 times 0.1 plus 0.71808 times 0.3, which is obviously,
All right. So when you just work that out, then you get something that's very close to 0.75. So that's the summary of this particular outcomes of this particular policy according to these various parameters that we've chosen.